Right. So today we're actually going to start a new topic, and we're going to start dealing with molarity. And in simple terms, molarity is moles per liter. So when we talked about moles, we talked about how moles connected grams and bulk mass. So now we're going to extend that definition and talk about molarity, which is the number of moles of a particular solute that's dissolved in solution. All right. So this is moles of solute over liters of solution. All right. So that's the general idea behind molarity. So we're going to talk about several things. Try to be brief about that because I really want to just get into the numbers and the calculations. But we're going to talk about properties of solutions. All right. We're going to talk about concentration, which is going to be represented by uppercase M for molarity. And then we're also going to talk about dilution. You probably have seen this. Right, you've seen it, probably seen this equation before, M1V1 equals M2V2. In the book, it may have C1V1, but M and C are both representative for concentration. Right, so C1V1 equals C2V2. Right, so we're going to talk about that. So if we remember from when we first started talking about mixtures and elements and homogeneous and heterogeneous, when we talked about solutions, right? A solution is a homogeneous mixture, right? And the fact that it's homogeneous means that it is uniform throughout. If you dissolve up, let's say 10 grams of sugar in water and you get it to dissolve and go completely into solution, every spoonful of water that you take out of that solution is going to have the same number of sugar molecules, the same amount of sugar, because in a solution it is uniform, right? So that component of what's dissolved is going to be the same for every aliquot that you remove from that solution, right? So you have every solution has a concentration. Right? Solutions have a concentration, and the concentration of a solution is just the relative amount of a given solution component, right? So when we talk about the concentration, what we really are talking about here is the moles of solute divided by the volume of solution. And this is always going to be expressed in liters, right? So when you have a solution, you probably already know this, you remember this from high school more than likely. You have two things that make up a solution. You have a solute and a solvent, right? So right, so the solute is the solid or whatever you're adding to the medium right? So the solvent is the medium, and then the solute is what gets dissolved. Right, so the solute is usually present in a smaller amount than the solvent. The solvent is the medium. This is the medium in which you're dissolving up whatever your solute is. An example would be like the if you were making ramen, right? All of us have done that, especially I know in college, you eat, y'all may have money, but I didn't. So I used to eat noodles like religiously. But the water that you cook the ramen in, that would be considered your solvent. And then the little seasoning package, when you add it to the water and get it all nice and dissolved up, that will be considered your solute. So your component that's being dissolved is the solute, and then the solvent is what was doing the dissolving, right? And then the way we characterize solutions, we call them either dilute solutions. That means that the concentration is low. And I'm gonna abbreviate solution as SOLN. That means low concentration. Right. And then if we have a concentrated solution, that's how we describe a solution that has high concentration. Right. And what we mean by when we say high or low concentration is basically the amount of solute per liter. So a high concentration is going to have a higher amount of solute per liter than something that is of a lower concentration. All right. So again, we measure the concentration of a solution with molarity. And you'll see that represented as big M or uppercase M. And again, that is moles of solute per liters of solvent, or I'm sorry, per liters of solution. Notice I didn't say liters of solvent because the solute and solvent are separate. But when you mix them and the solute gets dissolved in the solvent, they become a solution. So it's moles of solute divided by liters, not lights. Apologize for that. Liters of solution. All right. So let's just jump right in and do some examples. If we have let's say, and this is going to help us with thinking through these calculations as well. So if we have a 375 milliliter solution and it contains 0.266 moles of solute. All right. And the question is, what is the concentration? Right. So this is a very basic calculation. If we think about the concentration M being moles over liters, well, you have moles of solute and liters of solution. Right. We can figure this out. We have the numbers. We just need to make sure that everything is in the proper units. So it gave us 375 milliliters of solution. What that means is if we need liters of solution, we need to take milliliters and convert into liters. Your volume always has to be in liters. Right, so we know that 375 milliliters, all we need is a conversion factor. So 1 liter divided by 1,000 milliliters. So milliliters is going to cancel. And that's going to leave us with 0.375 liters. Once we have this number, we're home free. We just plug and play. So now we need to calculate. So it'll be 0.266 moles divided by 0.375 liters. And that'll be our concentration. Can somebody give me that number real quick? .266 moles divided by 0.375 liters. Anybody got it yet? All right, 0.709 mole, right? And when you write big M, it's understood what the units are. It's moles per liter. All right, let's do another example. We just gonna work through because the best way to do this, we know what a solution is. We know that a solution is homogeneous. And so now the best way to work this is just work through multiple examples. So let's do another example. And let's figure out, because you can manipulate this, right? Anytime you have an equation like this, right? Look at the terms. Anytime you have that, you can manipulate it. You can find volume, which is in liters. You can find moles, or you can find concentration depending on what two values you're given. So in this next example, if we're given the molarity, we got a 0.375 mole. Come on, Russell. 0.375 molar solution. And the question is, how much solute is in 10 milliliters of that solution, right? It's homogeneous. So we know we can take out 10 milliliters and we're going to get a specific number of moles in that 10 milliliters. So remember, if M is moles per liter, how do we find the moles of solute? Let me put that in here, in moles. How do we manipulate that to find moles?
Would you multiply liters?
Multiply both sides by the volume. Yep. So it'd be moles times liters equals moles. So then now we have our numbers, right? We have 0.375 molar. And then we're going to multiply that by 10 milliliters, or do we need to do a conversion? Because remember, the molarity is always going to, that big M is always going to be expressed in moles per liter. So if those are my units, when I multiply this thing, I need to make sure that I take that into account. All right. So 10 milliliters, let's convert that. Let's just do it in here inside the bracket or the parentheses. Sorry. So this is 10 milliliters times 1 liter over 1,000 milliliters. So milliliters is going to cancel. So that's going to be 0.1010. Is that right? All right. So then we just multiply those two together. So 0.010 liters times 0.375 moles per liter. How many moles do we get? Anybody got it?
Is it 0.00375?
Okay. Yep. We'll take that. We're going to go ahead and round it up to 0.004. But yes. All right. Let me throw in something. What if the solution was cobalt 3 chloride? How many grams? I'll zoom out in a second. How many grams, if the solution was made up of cobalt 3 chloride dissolved up in water, how many grams of cobalt 3 chloride did we use? What's your strategy here? What are you going to do here? What do we need to know? About 0.70. Is that your answer for grams of cobalt, Tramaria, or is that for something else? All right. How many
That was
grams?
for the first problem we did. My bad.
Okay. All right. How many grams of cobalt 3 chloride did we use? What do we need to know in order to go from moles to grams?
Molar mass.
Molar mass. Come on. Molar mass. We need molar mass / molecular weight. How do we get that? We need to know what we need the formula, don't we? For cobalt 3 chloride. Is that right?
Yes.
All right. Somebody give me that formula. What is the molecular formula for cobalt 3 chloride?
Would it be COCO3?
Who is that coming with the 5?
Alexis?
Come on, Alexis. You said COCl3.
Yes.
I agree 100%. Cobalt 3 is cobalt 3 plus. Chloride has a -1 charge. So this is the formula. Now we need the molar mass. We just need the atomic masses of cobalt and chlorine. Chlorine is 35.35, and we're going to multiply that by 3 because that 3 chlorines present. What's cobalt off the periodic table? It's a transition metal, and we know the symbol for it is CO. I think it's right before you get to gold. I think.
I
I
see.
got oh, go ahead.
No, you can go ahead.
I got 58.93.
8.93. And this is, remember, what's listed on the periodic table is AMU, but you know that AMU and grams per mole are interchangeable. So we're going to put in here grams per mole, and we're going to put here whatever we get from this in grams per mole. What do we have? Is that 105.105? For the chlorine, 3 times the atomic mass of chlorine.
One oh six point oh five.
106. Good. All right. So when we add those two together, 106.05 plus 58.93, what do we get? Let me see. That's 1.03. 58, was it 165.03? Is that what you have? Not 03, 08. I'm tripping. 164.98. Is that right?
Yes, sir.
All right, 164.98 grams per mole. All right, so now we know, now we can figure this out now because we know our little equation. Molar mass is grams per mole. And if we manipulate that, moles times molar mass is grams. Or how do we find, we're looking for grams, right? How many grams? So this is what we need, moles times molar mass. So we know the moles, we know the molar mass. Let's go ahead and calculate that. So grams of cobalt chloride, cobalt 3 chloride is going to be 164.98 grams per mole times, how many moles did we get? Point something, 0.004. All right, somebody pop that into your calculator and tell me what you get. Anybody got it yet? my calculator up. I'm getting 0.659992. We're gonna go ahead and round that up 0.66 grams. Anybody else get that?
Yes.
Mhm. All right. So what that means is that when we made, like if you were in the lab and you're a TA and your instructor said to make a 0.375 molar solution of cobalt 3 chloride, this is what you would do. You would take and a 10 milliliter solution of 0.375 molar cobalt chloride. This is what you would do. You would take 0.66 grams and you would dissolve that up in 10 mils. 0.375 is pretty concentrated. All right. So you dissolve that up in 10 mils of water. All right, let's do another one. So let's take the molarity. Let's figure out the molarity from the mass, right? Because we can do that. We can take the mass and turn it into moles. We know the connection there, and then we can divide that by the volume of solution to get the molarity. So this is a solution of cobalt 2 chloride. And it contains, we're going to take 6.52 grams and 75 milliliters of water. So this is the question is, what is the molarity? All right. So what's the molarity for this solution? All right. So what do we do? What do we need to do? If we're trying to calculate molarity, which is what we're looking for, what do we have? We have grams of solute and we have a volume, but it's just not in liters. Is that right? But molarity is what? What are my units for molarity?
Molarity is the units are moles over grams or grams over moles.
So no, that you think about molar mass. Molar mass is grams.
Oh, okay.
But molarity, big M, is moles per liter. So we need to find out how to get moles. So we have a mass of a given compound, which we can get the molar mass of by just adding the atoms together. And then we also have a volume, but it's not in liters. So let's get the molar mass of cobalt chloride, right? Cobalt we had up top was 58.93. And there's only one of those. And then chlorine is 35.35 times 2. Is that right? Because there are 2 chlorines. And so let's sum those up. It's going to be 70.70. Is that right? Grams per mole. And then the top 58.93 grams per mole. So what's the total there? Is that right? 136.63. No, sorry. 15, 70. $129.63. Is that right? $58.93 plus 70.70. Yeah. All right, so this is our molar mass. So we can take this and take the grams of cobalt 2 chloride and divide by that. Was it 6.52? Is that right? Are we on the right track? So what do we have for that? What is my what are my moles? Anybody got this? 0.0503.
I did.
All right. Why you say nothing?
I just got it as you was writing it down.
Okay. All right. All right. I'm gonna give you a pass because it's Wednesday. All right. So now we got moles. We know our volume. We need to convert that into liters. So it's gonna be 75 milliliters times 1 liter over 1,000 milliliters, and that's going to cancel. So we end up with 0.075 liters. So now it's just a plug and play. We're going to take the number of moles. So the molarity is 0.0503 moles divided by 0.075 liters. That's it. So once we calculate that, we'll have the molarity for a solution of cobalt chloride, cobalt 2 chloride, that consists of 6.52 grams of cobalt 2 chloride dissolved in 75 milliliters of water. All right. And if you calculate that, you should get 0.674 roughly molar. And when you see this written like that, you can write it. If you were to write it out, you would say 0.674 molar solution. That's how you'll see it. Like if it gives you the concentration, it'll say a 0.674 molar solution of such and such is, contains such and such number of liters of water, blah, blah, blah. But sometimes you'll see it written like this, a 0.674 molar solution. And then you understand that molar to be big M, right? Moles per liter. All right. We got time to do we got time to do one more. I'm gonna let y'all solve it. First person with the answer gets lunch today. All right, let me write it out, and then I'm gonna zoom out so you can. Hopefully my little stylus will work, so I don't have to zoom in. Let me see. Man, I screw this thing up. God dog it. Never mind. All right, so how many grams of calcium chloride are contained in 250 milliliters of a 0.2 molar solution? First person to answer that correctly. All right, no problem, Saxton. First person to answer that, let me start recording. First person to answer that correctly